and welcome back to Sustainability Ventures, where we look beyond headlines and into the data itself. When we hear statements like, the planet has warmed by X degrees, we assume those numbers are straightforward measurements. But here's the rarely discussed truth. Temperature data doesn't come ready-made, it's processed. Today, we'll explore how the way temperature data is collected, adjusted, and analyzed can influence climate conclusions without denying the reality of climate change. Global temperature records are built from multiple sources: ground-based weather stations, ocean measurements from ships and buoys, satellite observations. Each source measures temperature differently, with different coverage and limitations. Before scientists can even calculate a global average, these data streams must be combined, and that requires decisions. Raw temperature data is messy. Stations move, instruments change, cities grow around sensors. To account for this, scientists apply adjustments, such as correcting for station relocation, adjusting for time of observation changes, estimating missing data. These steps are necessary, but they are not neutral. Different methods can produce slightly different results. As cities expand, concrete, asphalt, and buildings trap heat, a phenomenon known as the urban heat island effect. Many long-term weather stations now sit in urban or semi-urban areas. Scientists attempt to correct for this, but urban growth is uneven. Corrections rely on assumptions. Not all stations are equally affected. Small biases at thousands of stations can influence global trends. Oceans cover over 70% of Earth, but measuring them accurately has been historically difficult. Early measurements used buckets lowered from ships, engine intake thermometers. Modern systems use automated buoys and floats. Each method has its own bias. Adjusting old data to match new systems is essential, but again, it introduces uncertainty. Satellites don't measure temperature directly. They measure radiation, which is converted into temperature estimates. This requires complex algorithms and calibration. Interestingly, satellite and surface records have sometimes shown different warming rates, highlighting how processing choices matter. Over time, revisions narrow the gap, but the debate reveals the sensitivity of conclusions to methodology. Homogenization is the process of smoothing data to remove non-climate influences. While necessary, it can reduce natural variability, alter regional trends, and create dependence on model assumptions. The goal is clarity, but transparency is crucial so independent researchers can verify results. None of this means temperature records are fake or meaningless. It means climate conclusions are built on layers of interpretation. When uncertainty is acknowledged, science becomes stronger, not weaker. Understanding data processing helps us ask better questions and build better policies. Climate science doesn't fail because it processes data. It fails when that processing isn't clearly explained. Informed debate requires openness, not blind trust or outright dismissal. If this video added clarity, like, subscribe, and comment below. Should climate datasets be more transparent to the public? Thanks for watching, and remember, better data leads to better decisions.